Imagine standing on a bridge, inside a towering skyscraper, or in a crowded stadium. You're surrounded by steel and concrete, trusting that the structure holding you up is safe. But what happens when that trust is betrayed? History is filled with terrifying moments when magnificent structures failed, leading to catastrophic consequences. These are not just tragedies. They are powerful, unforgettable lessons written in twisted metal and rubble, lessons that have forever reshaped the world of engineering. Our story begins in 1940 with a brand new bridge in Washington state. The Tacoma Narrows Bridge was a marvel of modern design, sleek and elegant. But it had a secret. In even moderate winds, the bridge deck would ripple and sway in an unsettling dance. Locals nicknamed it Galloping Gertie. With its support gone, the apartment above collapsed. Engineers at the time thought it was a harmless quirk. They were wrong. On November 7, 1940, just 4 months after opening, the wind picked up. The gentle ripples grew into violent, twisting oscillations. The bridge bucked and heaved like a wild animal until, in a final, spectacular failure, the entire central span tore apart and plunged into the water below. Miraculously, no human lives were lost, but the lesson was clear and dramatic. Engineers had underestimated the power of the wind. They learned that bridges aren't just static objects. They are dynamic structures that interact with their environment. The collapse of Galloping Gertie directly led to modern wind tunnel testing and the development of aerodynamic designs that ensure today's bridges can withstand nature's forces. Fast forward to 1981, Kansas City. The Hyatt Regency Hotel was hosting a popular dance competition. The atrium was packed with people, celebrating on the ground floor and watching from 2 suspended walkways that crisscrossed above the crowd. Without warning, a sharp crack echoed through the building. The upper walkway, loaded with spectators, suddenly collapsed onto the one below it. Both then fell to the lobby floor, crushing the people beneath them. It was a scene of absolute devastation. 114 people lost their lives in one of the deadliest structural failures in American history. The investigation revealed a small but fatal design change. The original design called for single, long rods to suspend both walkways from the ceiling. However, a contractor proposed a change to use 2 separate, shorter rods. This seemingly minor alteration doubled the load on the connection points of the upper walkway, causing them to fail catastrophically. The tragedy exposed a critical breakdown in communication between the engineers, architects, and contractors. As a direct result, building codes were strengthened, and peer review, where an independent engineer checks the original design, became a standard, non-negotiable practice in structural engineering. Now let us travel across the Atlantic to London in 1968. Ronan Point was a 22-story residential tower built using prefabricated concrete panels, a new and supposedly efficient construction method. Early one morning, a resident on the 18th floor lit a match for her stove, triggering a small gas explosion. The force of the blast was enough to blow out the exterior wall panels of her apartment. What happened next was unthinkable. This set off a chain reaction, and one entire corner of the building crumbled all the way to the ground, floor by floor. 4 people were killed. The investigation uncovered that the connections between the prefabricated panels were too weak to handle an event like an explosion. It introduced engineers to the terrifying concept of progressive collapse, where a single, localized failure triggers a domino effect, leading to a much larger disaster. The Ronan Point collapse forced a radical rethinking of building design. It led to modern requirements for structural robustness and redundancy, ensuring that buildings are designed to redistribute loads and remain standing even if part of the structure is damaged. Our next story takes us to Canada, and it's a failure so monumental it happened twice. The Quebec Bridge, designed to be the longest cantilever bridge in the world, was a project of immense ambition at the turn of the 20th century. During its construction in 1907, workers noticed that key steel beams were starting to bend. Before an evacuation could be ordered, the south arm of the bridge buckled and collapsed into the St. Lawrence River, taking 75 workers with it. The inquiry found that the engineers had simply miscalculated the bridge's own weight. The design was fundamentally flawed. It was a devastating blow to the engineering community, but the project was too important to abandon. Construction began on a new, redesigned bridge. Then, in 1916, As the massive central span was being lifted into place, a piece of hoisting equipment failed. The 5,000-ton section fell into the river, killing another 13 workers. The double failure of the Quebec Bridge became a symbol of engineering hubris. It taught a harsh lesson. Structural analysis must be absolutely precise, and safety margins must never be compromised. The tragedy reinforced the critical importance of independent reviews and a conservative, cautious approach to megaprojects, a principle that still governs bridge engineering today. In 1995, the world witnessed one of the most horrifying structural failures of the modern era in Seoul, South Korea. The Sampoong department store was a bustling, five-story shopping center. On a busy afternoon, shoppers heard strange cracking sounds. But before anyone could react, the entire north wing of the building pancaked, collapsing into its basement in less than 20 seconds. Over 500 people were killed, and nearly 1,000 were injured. The investigation revealed a chilling story not of miscalculation, but of greed and criminal negligence. The building was originally designed as a four-story apartment complex, but the owner illegally added a fifth floor to be used as a restaurant. To do this, support columns were cut to make space for escalators, and the heavy air conditioning units were moved across the roof, further weakening the structure. Warning signs, like massive cracks in the ceilings, were ignored by the management for months. The Sampoong collapse was a profound moral failure. It proved that ethics in engineering are just as vital as calculations. Cutting corners, ignoring safety, and prioritizing profit over people costs lives. In its wake, South Korea drastically strengthened the enforcement of its building codes and established strict accountability for engineers and building owners. Our final story takes place in Shanghai in 2009. Residents in a new housing development woke up to an unbelievable sight. One of the 13-story apartment buildings, part of the Lotus Riverside complex, had fallen over. It had tipped completely on its side, almost perfectly intact, like a giant domino. Thankfully, the building was unoccupied at the time, but one worker was killed. What could cause a brand new building to simply fall over? The answer lay buried in the ground. An underground garage was being excavated on one side of the building, and the excavated soil was piled up 10 meters high on the other side. A period of heavy rain saturated the soil. The combination of the deep pit on one side and the heavy, waterlogged pile of earth on the other created a massive imbalance of pressure. The foundation pile snapped, and the building simply toppled. This disaster was a stark reminder of the importance of geotechnical engineering, the science of how structures interact with the soil and rock beneath them. It highlighted that a building's foundation is just as critical as the structure itself. The Lotus Riverside collapse raised global awareness about proper site investigation and the complex relationship between soil mechanics and structural stability. So, what have we learned from these catastrophic failures? Galloping Gertie taught us to respect aerodynamics. The Hyatt Regency taught us the vital need for clear communication and peer review. Ronan Point showed us the danger of progressive collapse and the need for redundancy. The Quebec Bridge underscored the importance of accurate calculations and safety margins. Sampoong demonstrated that engineering ethics are non-negotiable. And Lotus Riverside reminded us that a building is only as strong as its foundation. From these tragedies, a new era of engineering was born, one where we test designs for real-world conditions like wind, earthquakes, and soil behavior. One where communication and professional ethics are paramount. One where we design for redundancy, so that one small failure doesn't become a catastrophe. In engineering, every failure, no matter how tragic, is a teacher. The structures that fell gave birth to stronger codes, smarter designs, and ultimately, safer cities for us all. Failure is not the end. It is the beginning of wisdom. Thanks for watching.